Dear students, this video is very useful to writing well in the upcoming JEE mains exam and very useful for quick revision for all the concepts which were given in the previous JEE mains examinations. Learn the information related to those concepts carefully and on which concepts should the questions in the previous exam paper be marked. And it is necessary to know which concept questions were asked in the previous years. That's why I prepared this video with a detailed explanation of previous JEE mains examinations. In the previous examination, this model was given. If the Thomson model of the atom was correct, then the result of Rutherford's gold foil experiment would have been. So these options are given. Before analyzing these options, I will explain the concept of these two atomic models, Thomson model and Rutherford's model. So in Thomson model, electrons are embedded within the mass, just like watermelon. In watermelon, seeds are embedded within the red mass. So that's why they are fixed in the red mass. That's why it is called watermelon model. So in Rutherford's atomic model using alpha ray experiment, in that alpha particles maximum, alpha particles penetrate through the gold foil, then most of the atom is empty. Very few alpha particles take deviation by small angles. They deflected by small angles with reduced speed because mass is positively charged and alpha particles are also have positive charge. Both are positively charged particles. That's why repulsion produced in between them. Right? By using these two concepts, we can analyze the options now. All of the alpha particles pass through the gold foil without decreasing speed. So it is only fairly Rutherford's experiment. So alpha particles are deflected over a wide range of angles. It is also Rutherford's because positive charge and alpha particles are so positive charge. Due to repulsion in between them, the deflected over a wide range of angles. They deflected. Right? Now third option, all alpha particles get bounced back by 180 degrees. So here, when it is bombarded directly with nucleus, it bounced back in 180 degrees. It is also pure Rutherford's alpha ray experiment. In D option, alpha particles pass through the gold foil deflected by small angles and with reduced speed. Yes, because alpha particles are positively charged and mass also positively charged. Then they deflected by small angles. Then speed also reduced. That's why D option is correct option. So this one you have to analyze the options like this. Dear students, next another important one, isotopes. So isotopes I will give simple definition. Same atomic number but different atomic mass. You have to remember this simple way. Isotope means same atomic number but different atomic mass. And next important term in this is isobars. In this definition, simple definition, same mass number but different atomic numbers. So this is the simple short way of definition of isobars. Same mass number, Same mass numbers but different atomic numbers. You have to remember simplify. So in next one is isotones. Isotones. Right, in this definition, these are having same number of neutrons. But different atomic numbers and atomic mass numbers also. This is the short way. Same number of neutrons but different atomic numbers and atomic mass numbers also. How can we calculate the neutrons? Number of neutrons is equal to A minus Z. A is the atomic mass, Z is the atomic number. That is the simple way to calculate the number of neutrons. Right. Next, another important term, isodiaphers. So in this simple, you have to remember in simple way, that is very easy. Dear students, this is very, very easy. Which are having same isotopic number are called isodiaphers. Right? How can we calculate isotopic number? Isotopic number is equal to A minus 2Z. So here A is the atomic mass, Z is the atomic number. So which are having same isotopic number. So those are called isodiaphers. Right? These are having different atomic mass and atomic numbers also. Next, in last one is in this isostars. Isostars. So these are having same atomicity. Atomicity means same the number of atoms present in the molecule. That is known as atomicity. And having same number of electrons. That means these are isoelectronic species. Same number of electrons. I will explain with one example. So CO2, carbon dioxide, and N2O, nitrous oxide. N2O, nitric oxide. Here atomicity is 3. 1 carbon, 2 oxygen atoms. Here also atomicity 3. 2 nitrogens, 1 oxygen. Then number of electrons also same in this. So carbon atomic number 6, that has 6 electrons, plus oxygen 8. 2 oxygen atoms. 8 plus 8, the total 22 electrons. In nitrous oxide, nitrogen 7 plus 7, 2 nitrogen atoms, and oxygen 8, then it has 22 electrons. Both are having same atomicity and same number of electrons. These are known as isostars. Right? Now, based on this concept, so some important questions were given in previous examination. Those are, first one, which of the following forms of hydrogen emits low energy beta particles? So in that, tritium is the lightest radioactive element. It is the lightest radioactive element. So it has N by P ratio is 2/2. That's why it exhibits radioactivity. 2/1. 2/1. N by P ratio is equal to 2/1. Number of neutrons 2, protons 1. Tritium atomic number 1, mass number 3. So it has 1 electron, 1 proton and 2 neutrons. That's why N by P ratio is equal to 2 by 1. 2 by 1. Right. Now it emits beta rays. These beta rays are low energy beta rays. That's why the correct option in this is tritium. Tritium emits low energy beta particles because that is the lightest radioactive element. Right. In this next question, hydrogen has 3 isotopes: protium, deuterium, tritium. Right. They have nearly same chemical properties but differ in physical properties. They differ in. Hydrogen can exhibit 3 isotopes. One is protium. Protium means it has only 1 proton in its nucleus. That's why it is called protium. And deuterium, it is heavy hydrogen. It has 1 electron, 1 proton and 1 neutron. And tritium is third, 3, 1 electron, 1 proton, 2 neutrons. So that's why. So they differ in atomic mass because they are having different number of neutrons. That's why here in these options, so D option is correct option because number of protons, atomic number same, protons also same. Atomic number, these are isotopes, same atomic number. Electronic configuration, all are having 1 electron in their valence shell. That's why their electronic configuration is 1s1. Then they differ in atomic mass only. That's why D option is correct. Next, another important one is nature of light. Nature of light, in that first one is the characteristic properties of wave. In that first one, wave length, it is denoted by lambda. Wavelength means the distance between 2 similar points or 2 successive points of wave is called wavelength. Right, the distance. Right, you have some units for this. Units. So in units, 1 angstrom is equal to, dear students, you must and should remember the units also. 1 angstrom is equal to 10 power minus 8 centimeters. That is equal to 10 power minus 10 meters. 1 nanometer is equal to 10 power minus 7 centimeters or 10 power minus 9 meters. Right? 1 millimicron. 1 millimicron is equal to 10 power 10 angstroms. So you have to convert these units from one unit to another unit. You must and should remember these values. These are very, very important. And 1 picometer. 1 picometer is equal to 10 power minus 18 centimeters. That is equal to 10 power minus 12 meters. You must and should remember these values. Next, frequency. Frequency is denoted by nu. So frequency means the definition, simple definition. The number of waves that pass through a given point in 1 second is called frequency. Right? Now, how can we calculate the frequency of a wave? That is nu is equal to C by lambda, where C is equal to velocity of light. It has some values, that is 3 into 10 power 10 centimeter per second or 3 into 10 power 8 meter per second. So you have to remember, dear students, you have to remember these values compulsory. Right? So next one is wave number. Wave number. It is denoted by nu bar. Nu bar. So it is the reciprocal of wavelength. Wavelength. So it has units. Units. Centimeter inverse and the meter inverse. So frequency also has units in frequency. So that is second inverse or hertz or CPS, cycles per second. Then you have to take these units for frequency, and for wave number units centimeter inverse and meter inverse. You have to take these. Right, another important one, Planck's quantum theory. According to Planck's quantum theory, the energy of a quantum of radiation is directly proportional to the frequency of the radiation. By using this statement, so we can use E is directly proportional to nu. Then E is equal to h nu. Here h is the Planck's constant. Its value is 6.625 or 6 into 10 power minus 34 joule second. In ergs, 6.625 into 10 power minus 27 erg second. So these are the important values of Planck's constant. Then you have to convert this mathematical expression into E is equal to hc by lambda. That means c is the velocity, nu is equal to c by lambda. Then c value, you have to observe the c value also. C is equal to 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second, right? Then we use this mathematical expression also, right? Then you use another one important, that is E is equal to hc bar. This mathematical expression also nu bar, hc nu bar. This mathematical expression is also very important, where nu bar is equal to 1 by lambda, reciprocal of lambda. So that's why this is also very important. And another one is E is equal to n h nu. This mathematical expression also very useful, where n is equal to number of photons. Now n is equal to E by h nu. By using this mathematical expression, we can calculate the number of photons, right? This is very, very important one. Another important model is, this was given in the previous examination. Dear students, a 50-watt bulb emits monochromatic red light of wavelength of 795 nanometers. The number of photons emitted per second by the bulb is. To first you have to choose the suitable mathematical expression, that is equal to n into h nu, or E is equal to n hc by lambda. Now here c is equal to 3 into 10 power 8 meter per second. Then h is Planck's constant, 6.625 into 10 power minus 34 joule second. And n is equal to number of photons. E is equal to energy. E is equal to energy. Given value is in watts. No, 50 watt energy is given. Then you have to convert it into joules. So 1 watt is equal to 1 joule. Then that is 50 joules. Right? Next, another one is lambda. Lambda is given in nanometer. That is 795 nanometers. 795 nanometers. Then you have to convert nanometer into meters. 1 nanometer is equal to 10 power minus 9 meters. Then that is equal to 795 into 10 power minus 9 meter. Then these values you have to substitute in the mathematical expression. That is 50. E is equal to 50. That is equal to N. You have to calculate the N value. H 6.625 into 10 power minus 34. And C value is given. That is 3 into 10 power 8 meters by lambda value. So lambda is 795. 795 into 10 power minus 9. So all values are in meters and joules. Right? Now you have to simplify this one. So N is equal to 50 into 795 into 10 power minus 9 by upon 6.625 into 10 power minus 34 into 3 into 10 power 8. 10 power 8. Now you have to simplify these values. On solving, N is equal to, first you have to solve the powers. 50 into 795 by upon 6.625 into 3. Power, same on multiplication, this power will get 10 power 17. 10 power 17 we will get the third. Then on simplifying these values, we will get 2000 into 10 power 17. Right? Now that is equal to 2 into 10 power 20. 10 power 20. Now the number of photons. The number of photons per second is equal to 2 into 10 power 20. This is the correct answer. It was given in numericals. Right? That is integers, no? So this is also very important and very simple mathematical expression. So you have to remember these mathematical expression. Then you have to substitute these values with the same units. You have to convert units into SI units. Right? Then you will get the correct answer. Right? This is the correct answer. Next important concept, photoelectric effect. Photoelectric effect. Photoelectric effect. This is also very important. In this photoelectric effect, very simple definition. So this is the metal surface. The ejection of electron takes place when a suitable light or frequency fall on the surface of metal. So this is known as photoelectric effect. When suitable frequency is available, the ejection of electron takes place. That is photoelectric effect. Right? Now here we have one mathematical expression to calculate the photoelectric effect. That is E is equal to W plus KE. This photon energy, that is E is equal to H nu, is divided into two parts in this. One is work function, W is equal to work function, and another one is kinetic energy. This is Ke, kinetic energy of mv square, kinetic energy. Now here work is equal to h nu naught. Work function is equal to h nu naught. Here nu naught is equal to threshold frequency. That is equal to threshold frequency. Threshold frequency. And h is Planck's constant. We know very well. H is Planck's constant. H is Planck's constant, right? Now you have to substitute these values in that. E is equal to h nu naught. Instead of W, we use h nu naught plus kinetic energy. This is one mathematical expression. Or E is equal to h nu. Now h nu is equal to h nu naught plus kinetic energy. Right? Now to calculate the kinetic energy, Ke is equal to h nu minus h nu naught. We use this mathematical expression also. Or in simplification, we will get we will get another one also, hc by lambda minus hc by lambda naught, because here nu is equal to c by lambda, nu naught is equal to c by lambda naught. These are the important mathematical conversions. So you have to use these important mathematical expressions, right? These are very, very important. Now an important mathematical expression was given in previous examination. Mathematical problem was given in previous examination, that is the minimum energy that must be possessed by photons in order to produce the photoelectric effect with platinum metal is. Given threshold frequency of platinum is 1.3 into 10 power 15 seconds and H is 6.6 into 10 power minus 34 joule second. Dear students, this is very, very easy, simple mathematical problem. Then you have to write the first mathematical expression, that is E is equal to W plus kinetic energy. This is the mathematical expression for photoelectric effect. Then E is equal to h nu. H nu is equal to W plus kinetic energy. Now here W is equal to h nu naught, threshold frequency. Then h nu is equal to h nu naught plus kinetic energy. Right? Now here in this problem, kinetic energy of knocked electron is 0, because in the order to produce photoelectric effect with platinum, the minimum energy that must be possessed. That's why kinetic energy of knocked electron is 0. Then h nu is equal to h nu naught plus 0. Then h nu is equal to h nu naught. Right? Now here he asked the question only, that is work function. Now W is equal to h nu naught. Right? That is equal to h nu naught. Now here h is the Planck's constant. Now the given value is 6.6 into 10 power minus 34 joule second. and threshold frequency is also given, that is 1.3 into 10 power 15 seconds. So nu naught is equal to 1.3 into 10 power 15 second inverse. Then you have to substitute these values in this problem, that is 6.6 into 10 power minus 34 into 1.3 into 10 power 15, right? On simplification of powers, we'll get 6.6 into 1.3 into 10 power minus 19 joules. So when we multiply 1.3 with 6.6, we will get 8.58 into 10 power minus 19 joules. This is the important problem. So very simple problem. Simplification is very easy. Now another important given model is the work function of sodium metal is 4.41 into 10 power minus 19 joules. If photons of wavelength 300 nanometers, wavelength is 300 nano, are incident on the metal, the kinetic energy of the ejected electron will be. We have to calculate the kinetic energy. H is equal, given value 6.63 into 10 power minus 34 joule second, and C value is 3 into 10 power 8 meter per second. Now when a light fall on the metal surface, the ejection takes place, right? Means energy, suitable light or suitable frequency fall on the metal surface, the ejection of electron takes place. Then it is kinetic energy. And here the energy is work function. So this energy is divided in two parts, work function and kinetic energy. Now first, based on this data, so you have to calculate first energy. E is equal to H nu, right? Or E is equal to H C by lambda, because nu is equal to C by lambda, right? You have to substitute the values in this mathematical expression. Then H is equal, given value is 6.63 into 10 power minus 34 joule second. Then C value also given, that is 3 into 10 power 8 meter per second, right? You have to substitute these values. E is equal to H is 6.63 into 10 power minus 34 into C value 3 into 10 power 8 meter per second. On lambda value is 300 nanometers. You have to convert these 300 nanometers into meters. So lambda given value is 300 nanometers. Then 1 nanometer is equal 10 power minus 9 meters, right? Then 300 nanometers is equal to 300 into 10 power minus 9 meters, or 3 into 10 power minus 7 meters you can write. Then you have to use this value in lambda, 3 into 10 power minus 7, right? Now on simplifying this, E is equal to 6.63 into 10 power minus 19 joules energies. 3 cancel, no? Right, now value is E is equal to 6.63 into 10 power minus 19 joules. Now to calculate the kinetic energy of the ejected electron, now you have to use this mathematical expression in second step. So that is E is equal to W plus kinetic energy. Now E value already we know that. Then W, work function. So work function, right, that is given value. Work function of the sodium metal is 4.41 into 10 power minus 19. So W is equal to 4.41 into 10 power minus 19 joules. Now we know the E value and you have to calculate the kinetic energy. Kinetic energy is equal to E minus W. So we know the E value, that is 6.63 into 10 power minus 19 minus W value is 4.41 into 10 power minus 19. Then on subtracting this, we will get 2.22 into 10 power minus 19 joules, or 222 into 10 power minus 21 joules. This problem was given in integers, right? This is very, very important, very simple. Dear students, these model problems are very important and very simple, right? Now another simple model also given in the integer problem. No, this is also similar problem. So ejection of the photoelectron from metal in the photoelectric effect experiment can be stopped by applying 0.5 volts when the radiation of 250 nanometer is used. The work function of the metal is. It is also very easy, dear students. So very easy. So simple simple problem. So see. So wavelength of radiation is that is 250 nanometers. That is lambda is equal to 250 nanometers. 250 nanometers. Right. Now in the photoelectric experiment can be stopped. Ejection of electron can be stopped by applying 0.5 volts. Now here we use this mathematical expression first. H nu or E is equal to Hc by lambda. Right. Now here H is the Planck's constant. H is the Planck's constant. 6.625 into 10 power minus 34 joules. Now here given value is in volts. Then you have to convert joules into volts. Then 1 joule is equal to 6.242 into 10 power 18 electron volts. Then H value is equal to 6.625 into 10 power minus 34 into 6.242 into 10 power 18 electron volt. Then that is, on simplifying, you will get 41.354 into 10 power minus 16 electron volts. Then it is very, very easy problem. Then you have to convert these units to joules into volts. Right? Now you have to substitute these values in this mathematical expression. Now C is equal to, see how much? C is equal to 3 into 10 power 8 meter per second. You have to convert it into nanometers because lambda value is in nanometers, no? That's why. So 1 nanometer is equal to 10 power minus 9 meters. 10 power minus 9 meters. Then here we will get 3 into 10 power 8 by 10 power minus 9. So that is equal to 3 into 10 power 17 nanometers per second. Now we have to calculate by using these values. First, E is equal to H value 41.354 into 10 power minus 16, right? And C value is 3 into 10 power 17 by lambda value. The given lambda value is 250 nanometers. 250 nanometers, right? Now on simplifying this value, we will get 1240.62 by 250. Then on simplifying, we will get 4.9624 electron volts, right? This is the very simple simplification. Then now we have to substitute this value in photoelectric effect mathematical expression. Now E is equal to W plus kinetic energy. So E is 4.9624 electron volts minus now given kinetic energy is, that is 0.5 volts, 0.5 volts, right? So on subtract this, then we will get 4.4624 or nearly 4.5 electron volts. This is the correct answer. Dear students, you have to watch this video and practice. Then you will remember all concepts, important concepts, right? If you like this video, please subscribe.